Alright, so in this video we're going to try to match velocity versus time graphs to verbal descriptions. And again, the key thing to note here is that on these graphs, if you have a positive value, that means that you're going to the right because you have a positive velocity. If on the other hand you have a negative value, that is going to mean you're going to the left because you have a negative velocity. Another thing to remember is that farther from 0 is faster. And that doesn't matter if positive or negative, just farther from 0 is faster, the magnitude is larger. And so that's how we're going to start this. So what we might even want to do is look at the graphs and just identify what direction it's going. So if I look at graph A, this line is below 0, so this means it's negative, so this is moving to the left, and it's moving to the left the entire time. Graph B, if you notice, it's also negative the entire way, so this is also moving to the left the entire way. C, there's one area up at the beginning where it's positive, so that's moving to the right. It's poorly written, but you get the idea. And then there's an area where it is negative, and so that's moving to the left. Graph D is on 0, so it's not moving left or right, so that would mean it's not moving. Graph E is all positive, so that means it is moving to the right. Graph F is all positive, so that means it's moving to the right. Graph G is all negative, so that's moving left. And graph H is all positive, so that's moving right. So that might be how you want to start this, just jotting down some things. Then, is it getting closer to 0 or farther from 0? Well, graph A is staying at the exact same point. So that means it's not going slower or faster, so that would mean it's going at a constant speed. Graph B, you know, starts far from 0 and then it approaches 0, so that must mean it is slowing down. Graph C, this is a little tricky. At the beginning, it starts far from 0 and it reaches 0. So at the beginning, it's going to the right and it's slowing down. But on this next region, it starts at 0 and goes away from it. So not only is it going to the left, but it's also speeding up. This one we said graph D was not moving. Graph E started at 0 and then got further from 0, so it's speeding up. Graph F began farther from 0 and then got closer to it, so that was slowing down. Graph C started close to 0, got farther from it, so that's speeding up. In graph H, it does not change, so that is a constant speed. So before we even look at any of the descriptions, if we just go through each graph and jot down the basic idea, now the matching is a lot easier. So a car accelerates to the right from rest. So we're looking at something that's going to the right and that is speeding up. And so looking at this, graph E seems to be the best match because it starts off at 0 and then it gets faster and it's going to the right. Jack walks left at constant speed. Well, we have graph A for that. It's already written on our notes. Allison runs right and slows down. That's going to be graph F, as we see. A turtle lies motionless, so which one's not moving? That was graph D. A ball rolling left slows and comes to a stop, so that would be graph B. Again, we already have it all written down. It's just a matter of matching it up now. Paul starts at the starting line, begins running faster and faster to the left. That was graph G. Walks right at a steady rate. That was graph H. And a ball is thrown into the air, slows down, comes to a brief stop, and then falls, picking up speed. I know we said right and left, but remember I said right. It really doesn't always have to be to the right. It could be up if we want to consider that the positive direction. It could be, it's really whatever we decide. But the last graph is C, and that seems to describe that. So that's how I would go about this. Jot down some notes on each graph, and then just try to match it up, and then I think you'll have better luck. So until next time, I am Derek Genova. Have a delightful day.